Okay, so first we have to calculate the pressure at the interface of two liquid, that means at this point, and then at the bottom of this fluid at this point. So at these 2 points we have to determine the pressure. So first, pressure at this point is nothing but because of this, the oil which is above this particular point. Okay, so if I want to determine the pressure at this point, P is equal to what? Rho GH. Okay, rho we can determine, S1 is given, so rho is equal to 0.8 into 1000 as I have told you, into 9.81 into height is 2 meters. So this pressure from here will be equal to 15.69 kilopascal. Answer first thing. Okay, second, pressure at the bottom of the vessel. So this pressure at the bottom is because of this oil and because of this water, is equal to rho 1 GH1, this is rho 1 H1 plus rho 2 GS2. So just put the value. So rho 1 we have as 800 into 9.81 into height is 2 plus rho 2. Rho 2 is how much? So the specific gravity is 1 into 1000. So in 1000 into 9.81 into 4. So from here this pressure will be equal to 54.93 kilopascal. Answer. Okay, very simple to solve. Okay, so now very important note, for a given pressure measurement in two different fluids, suppose we are measuring the same pressure at two different fluids, so this pressure P will be equal to rho 1 GH1, which is also equal to rho 2 GH2. So we have two different fluids, fluid 1 and fluid 2. So pressure, because pressure is same, so this pressure will be equal to rho 1 GH1, which is equal to rho 2 GH2. Okay, or you can say this rho 1 G1, sorry, rho 1 H1 is equal to rho 2 S2, or you can say gamma 1 into H1 is equal to gamma 2 into S2. Okay, so this is very important conclusion. Okay, and I will tell you the application also of this conclusion. Okay, suppose for example, suppose it is given that the pressure at any particular point is 100 meter of kerosene. Okay, and you have to determine this pressure in terms of water column. 100 meter of kerosene, the pressure is given, we have to determine the same pressure in terms of water column. Okay, so very simple, as I told you, rho 1 H1 is equal to rho 2 H2. Okay, so now for kerosene, this S, for kerosene S is equal to 0.8. Okay, so rho will be equal to 0.8 into 1000, which is equal to 800 kg per meter cube. Okay, so this will be 800 into H1 is given as 100 meter is equal to, now rho 2 for water, density is 1000 as we know, into S2. Okay, so from here this H, height of water column, will be equal to 80 meter of water. Okay, so if the pressure is given in terms of one fluid, we can easily determine the same pressure in terms of other fluid by using this one, rho 1 H1 is equal to rho 2 H2. Getting this now? Okay, now we will solve one question. The pressure at the bottom of hill is 76 centimeter of Hg and at the top of hill is 70 centimeter of Hg. Then what is the height of the hill? Okay, now suppose this is our hill. We have the pressure at the bottom of the hill. The pressure is given as 76 centimeter of Hg. Okay, suppose this point is point 1 and at top of hill at point 2 pressure is given as 70 centimeter of Hg. Okay, now we have to determine the height of the hill. Okay, so सबसे पहली चीज़ तो ये समझना ज़रूरी है that why is there pressure difference between the 2 points at the bottom and at the top of the hill, pressure difference क्यों है? So one thing, as I told you, that we are living in an earth which is surrounded by atmosphere. Okay, and as we are coming down from the topmost layer of the atmosphere, as we are coming down, the pressure will go on increase because more and more fluid will be above us. Getting this or not? Okay, तो हिल के बॉटम में 76 सेंटीमीटर ऑफ एच जी, हम जैसे जैसे हिल के टॉप में जा रहे हैं, द प्रेशर इज डिक्रीजिंग एंड एट टॉप द प्रेशर इज 70 सेंटीमीटर ऑफ एच जी. Okay, and as I told you, this pressure difference is because of the air which is present between the hills. Getting this or not? That means अगर मुझे यहाँ की इस हिल की हाइट निकालनी है तो सेम प्रेशर डिफरेंस अगर मैं एयर के कॉलम में देखूँ, okay, so I will get the height. For example, suppose this same thing in terms of mercury, rho 1 H1 will be equal to rho 2 S2. Okay, Now in terms of mercury, the density of mercury as we know is 13,600, okay, into height. Okay, so change in height, we have to determine the difference in pressure. So the change in height is 76 minus 70. This is change in pressure between the top and bottom of the hills, and this is because of the एयर प्रेजेंट बिटवीन बॉटम एंड द टॉप. ओके, तो इस चीज़ को ध्यान से समझो कि इन दोनों के बीच में जो एयर प्रेजेंट है उस एयर के कारण इसका प्रेशर डिफरेंस हो रहा है. गेटिंग दिस नाउ? ओके, तो एयर के कारण अगर प्रेशर डिफरेंस हो रहा है तो यहाँ पर इफ आई टेक दिस फ्लूइड एज एयर and if I determine this height is nothing but the height of the air column between the two. Getting this or not? Suppose यहाँ पर here at this particular point here, suppose we have this hill. Okay, ये इसको इस तरीके से समझो, ये earth है and at earth we have this hill. Okay. Okay, so next question says the pressure at the bottom of hill is 76 centimeter of Hg and at top of hill is 70 centimeter of Hg. Then what is the height of the hill? Okay, so we have got one hill such that pressure at the bottom of this hill is 76 centimeter of Hg and at top of hill the pressure is 70 centimeter of Hg. Okay, we have to determine the height h of the hill. Okay. Now, the thing which we have to understand now is what is this pressure difference, the reason of this pressure difference. Pressure difference का आखिर कारण क्या है? What is the reason of this pressure difference? So, suppose this is our earth and we have got the hill, okay, and as we know this earth is surrounded by the atmosphere, okay. So, because of this air we feel the pressure at, suppose we are at the ground level, we feel some pressure because of the air above us and that is called as the atmospheric pressure. Okay. So, at top of the hill the pressure is because of this height, suppose this height is h2 and at bottom of the hill the pressure is because of this height h1. Getting this one? Okay. So, what we have to calculate here is h1 minus h2. That will be the height h of this hill. Okay, so करना क्या है कि हमको इन दोनों के बीच का प्रेशर डिफरेंस क्योंकि यहाँ पर दिया हुआ है, तो फ्रॉम हियर वी कैन कैलकुलेट दिस h1 minus h2. हाउ? ओके, सो प्रेशर बिकॉज ऑफ दिस pressure difference because of the mercury column is at the top of the hill the pressure is rho g h2. Okay, because of this height h2 at the top of the hill the pressure will be rho g h2 and at bottom of hill the pressure will be rho g h1. Okay, so this will be rho g h1 minus rho g h2 and this will be equal to rho g h because of this mercury column. Okay, that means rho g into del h of hg. Getting this or not? So whatever pressure difference we are getting, here it is 76 centimeter of Hg, here it is 70 centimeter of Hg. So because whatever pressure difference we are getting, that is because of this height. Okay, so this rho g h, the pressure difference is can be written as rho g h1 minus rho g h2. Getting this or not? Okay, further this can be written as this rho is for air here because we are surrounded with air. So this will be equal to 1.2 into 9.81 into h1 minus h2 is equal to rho of mercury is 13,600 into 9.81 into del h of mercury. Okay, so what is del h of mercury? So here we have 76 minus 70 centimeter of Hg, in terms of centimeter of Hg it is. So this will be 0.76 minus 0.7 in terms of meter of Hg. Getting this or not? Okay, so from here we can get the value of this h1 minus h2 which is nothing but h. So this h will be equal to what? From here you can calculate it and this will be equal to 680 meter. Answer. Getting this? How we can calculate this? Okay, now next you can write one note here. Okay, suppose you have three different pipes. One is of 120 centimeter, second is of 100 centimeter and third is of 150 centimeter, which is like this zigzag. Okay, and the length given is the length of the whole pipe. Now what will be the pressure in at these 3 points? At point 1, 2 and 3 we have to determine the pressure. Okay, so the pressure, the water level is up to this point In all the pipes the water level is up to this point. Okay, because this water level is up to this point only, and when we take this P is equal to rho g h, here this h is nothing but the effective vertical distance. This is very important. This is not the distance of the pipe, this is not the length of the pipe, this is effective vertical distance. Okay, so whether you take this pipe or you take this pipe or you take this pipe, the effective vertical distance will be this only. This will be our effective vertical distance, which is 100 centimeter. Getting this or not? Okay, so because this is at same level, so at same level all this all the pressure will be same. That means P1 will be equal to P2 will be equal to P3. Why? Because the vertical distance is same for all. Getting this or not? Okay, so related to this we will solve one question. Find the gauge and absolute pressure at point X. Okay, so here at point X we want to calculate the gauge pressure as well as the absolute pressure. Okay, so as I told you, the total pressure, the gauge pressure, if we want to calculate, this will be equal to rho g h. Okay, where h is the effective vertical height. Okay, and what will be the effective vertical height here? So this is, because this is 2, and if I and this angle is 30 degree. Okay, so this distance, which is effective vertical height, this will be equal to 2 sine of 30. Getting this or not? Okay, so the height is 2 sine 30, so this will be equal to rho is 1000 for water, okay, into 9.81, the fluid here is water, into height is 2 sine of 30 degree. Okay, obviously this will be the gauge pressure, not the absolute pressure. For absolute pressure we will have to add P atmosphere as well. Getting this or not? Okay, so from here this gauge pressure will be equal to 9.81 kilonewton per meter square. This is our gauge pressure. What about absolute pressure? So P absolute is equal to P gauge plus P atmosphere. Okay, so this will be 9.81 plus atmospheric pressure is 101.325. Okay, so this will be approximately 110.8 kilopascal. Answer. Getting this or not? Okay.